Okay, good morning. Today's session we see about fuzzy classification. Last session we have discussed about fuzzy logic controller, that is FLC. Now we will discuss about the fuzzy classification, how the classification can be done fuzzy. So first I would like to say about rule-based classifier. So rule-based classifier here is, you can see here, x1 and x2 on the two axes. So how, according to the rule, how we are going to classify? So where the classification is used. Normally we call it as a cluster. So clustering is, you're going to group the data. You're going to train the data first. That is, train the labeled data, and then you're going to group the data, and after grouping it, you're going to classify the data. So this classification, fuzzy classification, we are using in all the algorithms, like we are using supervised algorithms and semi-supervised algorithms. So these supervised and semi-supervised algorithms are using a classification in all biometric needs, and even in artificial intelligence machine learning we are using this classification. So you can see this diagram which explains x1 and x2. So what are the rules? What are the various rules? Rule 1 is, if x1 is S and x2 is yes, then class 1. So you're going to predict the classes. Rule 2 is, if x1 is S and x2 is not S, then we predict as class 2. Rule 3 is, if x1 is M and x2 is yes, then we predict as a class 2. Likewise, we can predict it if the x1 is M or x2 is not S, then class 1. X1 is not S and x2 is L, then class 1. If x1 is L and x2 is S, then class 1. If x1 is L and x2 is M, then class 2. So we are going to find the rule from the sample data. So from the sample data, you're going to train the data, and after training it, you're going to design the membership functions. Clustering is also done, and finally classification is done. So here a simple algorithm I have took, which is called as a k nearest neighbor algorithm, or it is called as a KNN algorithm. So KNN algorithm, you can see it is crisp KNN algorithm. You can see in the graph there are two classes, class 1 and class 2. So what is a k value? K is equal to 3. So k is nothing but the number of classes, that is number of items. So you can see here there are three number of items. You can see one plus is there, that is class 1, and class 2 is blue color, and also you have a brown color, which is another class. So totally you have three neighbors. There are three neighbors. Okay, you can't. So I'm going to check it as a two classes. Class 1 and class 2 classification is done using. So how we are going to differentiate class 1 and class 2? So you're going to know the class membership of labeled samples. Okay, so here I am after classification. So before we have seen the classification, before performing the classification, what would happen? Now we are seeing the graph which is after classification. Here we are going to differentiate the two classes. That is class 1 and class 2. Class 1, you can see one side you have all the plus, and class 2 you have all the blue color circles, rounds are there, and in between some points are there which is not predicted. So we are grouping that separately. We are clustering it separately. So class 1 is plus, you can easily identify who are the, say for example in the class itself, you go for the class, the person who takes below 50, the person who takes above 50, you're going to predict it and you're going to differentiate. So using this kind of an algorithm, we can easily identify without any calculation. We can say totally 10 numbers, 10 students have scored less than 50. 20 students have scored more than 50. So this classification will be used in such case. So you can see here, this algorithm will show you how to identify the classification. So how we are going to calculate or the fuzzy clustering. So the neighbors are more evenly weighted. That is, higher arrow mark will give you the M capital, that is small m. The neighbors are more evenly weighted, And the closer neighbors are far more heavily weighted than those farther away. Okay, so this formula will give you how to compute the membership, that is ui of y. And fuzzy nearest prototype classification. And this is a prototype classification, like how they are going to classify using a decision boundary. So you have a decision boundary, class 1 and class 2. And apart from class 1 and class 2, which are separate, you're going to take it. So even from the first cases which is not predicted inside our class, also you're going to make a decision boundary. That is decision boundary in the sense which is unwanted, also you're going to part it to whether it is a class 1 or class 2. Thank you.